This is again another question, the third question of cavity from IIT-JEE 2012 paper. A lamina is made by removing a small disk of diameter 2r from a bigger disk of uniform mass density and radius 2r as shown in the figure. Right. The moment of inertia of this lamina about axis passing through O and P is IO and IP respectively. Both these axes are perpendicular to the plane of the lamina. Then the ratio IP upon IO to the nearest integer is, right, IP upon IO. We have to calculate the value of IP upon IO, right? So let us see how we will solve the question. Since it was uniform mass density, the disk was of uniform mass density, let us assume that the mass density was sigma, right? Mass per unit area, right? So again, for cavity, what we will do? The same thing. We will fill it by plus sigma and minus sigma, right, respectively. So when we fill it by plus sigma, we will calculate these two values, right? This is point O and this is point P. So for point O, when we fill it by plus sigma, IP1, let us call this IP1, this will be equals to, for moment of inertia for disk is given by half mr square, which will be equal to half into m, which is sigma into pi into 2r whole square, m into r square, which is equals to 2m r square, right? This is IP, sorry, this is IO, this is IO, this is due to point O. Now what will be IP? IP will be equals to what? IO plus m into 2r whole square, right, which will be equals to, this is IP1, this will be equals to half into sigma pi 4r square, right, into 4r square plus sigma into pi into 4r square into 4r square, right? This is IP1. Now we calculate IO. Due to this, there is a disk which is having a mass density minus rho, minus sigma, right? So we have to calculate at O point, right? It is having a radius r. So what will be IO? Let us call this point as A. IO. Now since A is the center of mass, so that means IO will be given by IA plus m r square, right? And IA, about the center of mass of this body, that will be equals to what? Sigma into pi r square, this is the mass, into the r square, mr square, right, plus mr square. What is the mass now? Sigma into pi r square into r square, which will be equals to basically 2 sigma pi r raised to power 4. This is IO2, right? This is IO2. Now IP2, what will be that? IP2, what will be that? Now IP2 is given by I center of mass plus m into x square, where x is the distance between the point P and the center of mass, right? This is the formula basically. I center of mass is again IA, which will be equal to what? This will be equals to sigma into pi r raised to power 4 plus mx square, which will be equals to sigma into pi r square. What will be x? This distance is 2r, this is r, so x will be equals to root 5 into r. So this will be equals to 5r square. This will be equals to 6 sigma pi r raised to power of 4, right? So we got IO2, we got IP2, we got IP1, we got IO1. So what I'll do is I need to calculate IP by IO, which will be equals to IP1 minus IP2 divided by IO1 minus IO2, right? So this will give us, let us calculate it over here. So IP will by IO will be equals to, now what is this value? This is like we can multiply it, 8 and this is 16, this is 24 sigma pi r raised to power of 4, right? This is IP1 minus of IP2. IP2 will be equals to 6 sigma pi r raised to power 4 divided by IO. What will be IO? It is half of this, which will be equals to, IO is 8 sigma pi r raised to power 4 minus of IO2, which is 2 sigma pi r raised to power of 4, right? This was r. So which will be equals to sigma pi r raised to power 4 can cancel out. So this will be 18 divided by of 6, which will give us the answer 3. So that means 3 is the correct answer.